answers, and those are all great, or you're able to figure it out from my work. Now let's take one more step. This time, we're going to look at limits of functions that have holes. So a hole is just like one little part of the function that's undefined, or it's defined elsewhere, like on that. So in this example, right, there's a hole at 2, 4. So as f of 2 is undefined because there's nothing there, but the limit as x approaches 2 is still 4 because the limit from the left and the limit from the right are both equal to 4. So if you remember, what's actually happening at 2, what's actually happening at f of c doesn't matter at all for limits. All that matters is what happens as x approaches c. So that means that we could cancel out this hole, and I'll show you how to do that, so that it turns into that's not good. It turns into a solid function, and then it's very clear the limit is 4. And the way we do that is by canceling out factors that are in both the numerator and denominator. And I'll show you what that looks like. Okay, so we want to find the limit as x approaches -3. Now, if we were to plug in -3 like we've been doing, the numerator would go to 9 minus 3 minus 6, which is 0. And the denominator would go to -3 plus 3, which is 0, right? So we're left with 0 over 0, which is called as indeterminate form. It just means you can't divide by 0. So it doesn't give us, it's not undefined, it's this nebulous, it could be anything kind of situation. So we don't have an answer from that. So what we need to do instead is factor. So turn this into the limit as x approaches -3 of factor the numerator. So what multiplies to -6 and adds to +1, that would be a +3 and a -2. And then the denominator can't factor, it's just x plus 3. So notice there's a common factor here, x plus 3, x plus 3. So those cancel. And this is now equivalent to the limit as x approaches -3 of x minus 2. Now we could plug in -3. -3 minus 2 is -5. So that is our limit, -5. So again, the steps were, see if you plug in and get an answer. If you get 0 over 0, you need to do something. That something so far is to factor, cancel, and then plug in. Okay, so let's take a look at the next example. We've got the limit as x approaches 0. Again, if I plug in 0, I'll get 0 minus 0, which is 0, over 0 plus 0, which is 0. 0 over 0 tells me I need to do something. So I'm going to factor. So this is the same as the limit as x approaches 0 of, okay, what do they have in common that I can factor? A 5x. So it leaves me with x squared minus 1 over the denominator. I can factor out an x, so that's x plus 1. Okay, so now I see that there is an x in both of them, so I can cancel out that x. And now I have the limit as x approaches 0 of 5 times x squared minus 1 over x plus 1, because the x is canceled. All right, so now I can plug in 0 and get 0 minus 1, 0 plus 1, which is just -5 over 1, or -5. Okay, I'll do 2 more examples, and then you're going to try some yourself. Here we've got, if you plug in -1, it's going to get you 0 over 0. So instead we're going to factor. Truth is, honestly, you could factor and cancel even if it doesn't get you 0 over 0. It'll still give you the same limit. Okay, so this equals the limit as x approaches -1. And I want to factor the numerator and factor the denominator. Okay, so I have to think what multiplies to 5 and adds to 6. So that's a +5 and a +1. And then I need what multiplies to -4 and adds to -3. So that's a -4 and a +1. Most likely there'll be a factor that's the same, so use that to help you figure that out, the factors. Okay, so these cancel. So I'm left with the limit as x approaches -1 of x plus 5 over x minus 4. So that's -1 plus 5 over -1 minus 4, so that's 4 over -5. Okay, and last example, the limit is x equals 5. Again, you're going to get 0, 0, so we need to factor. So this is the same thing as saying the limit as x approaches 5 of an x squared minus 25 factors into x plus 5, x minus 5, the difference of two squares. Now here's interesting, 5 minus x, right, is not going to cancel with x minus 5. But if I factor out a -1, or just a negative, this becomes x minus 5, right? Because that's negative x and a positive 5. So that's a nice little technique you can do when you're trying to factor with subtraction, but they're in opposite places. Just factor out a -1. So now I can cancel out x minus 5, x minus 5. Take the limit as x approaches 5 of x plus 5 over -1. So that's 5 plus 5 over -1. That's a -1, which is -10. Okay, so now just to summarize what I just went over, there's basically 3 steps you take when finding limits analytically, which means like from a function. Step 1, if you plug in the number you're going to and you get a number, you're done. That is the limit. If you plug in and get 0 over 0, try factoring, canceling, and then plug in. Go back to step 1. If you can't factor and you still get 0 over 0, there's more methods. We just haven't learned them yet. So for today, everything's going to be factor, cancel, plug in. And lastly, if you plug in and you get something that's not 0, but 0 is in the denominator, right? Anytime you divide by 0, that's undefined. The limit does not exist. Just for your own knowledge, there are 3 situations that could happen if you get a number over 0. It's always going to be a vertical asymptote, which means like a line that the graph is approaching but not touching. It could either be that you're going to positive infinity like this. It could be that you're going to negative infinity like this. Or it could be that one's going to infinity, one's going to negative infinity, so there is no limit because they're different from the left and from the right. In all of these situations, you can just say DNE, does not exist. You don't need to specify whether it's infinity, negative infinity, or actually doesn't exist. So again, every time you have a number over 0 after you plug in, the answer is the limit does not exist, DNE. Okay, for those of you who are visual learners, here's a flow chart that helps break it down for you, right? So start by plugging in A. If you get a number, including 0, 0 is a number, you're done. That's the limit. If you get 0 over 0, do something. And again, all we've learned so far is factor, cancel, and plug in. And if you get not 0 over 0, then the limit does not exist. Okay, so that's a succinct summary of everything from this lesson. I hope that's clear. I included all the notes from this video for your reference, followed by a problem set. In the problem set, you're going to, on a separate piece of paper, because it's too hard to write on the computer, just in an organized way, label them 1 through 10, show your workout, and then check your answers that I provided on the slides after that. If you got something wrong, go through my worked out solutions and see if you can find your mistake, or maybe I made a mistake and let me know. And if you're still confused with the problem, indicate that on your exit ticket and I'll go over it tomorrow, just so we're all super clear on this. Okay, so this is what the problem set looks like. Go ahead and get there in your pod.